Alright, welcome. Today we are discussing grade 11 geometry, but please take note that the grade 11 geometry is also applicable to grade 12s. Grade 12s are tested on both grade 11 and grade 12. You need to remember that. So in this section, we're going to discuss the one theorem only, which says line from the center of a circle drawn to midpoint of a chord is perpendicular to the chord. Now, you need to have an understanding of what exactly this means. The meaning is what we need in our study. So we are saying line drawn from the center. What it means is that, let's say we have a circle, and in the circle, there is a line that is drawn from the center of a circle. If a line is drawn from the center of a circle to the midpoint of a chord, now this is the line from the center. Let's say the center is O, then there is a chord going through like that. I'm going to call my chord P and Q. Now, if this line, which is coming from the center of the circle, is dividing the chord into two equal parts, then it means the line from the center and the chord, they are perpendicular to each other. That is what the theorem says. So in your examinations, if I say to you, the line from the center is passing through the midpoint of a chord, then you must be able to conclude that therefore there is an angle here of 90 degrees. The 90 degrees angle, we won't tell you. We will tell you that the line from the center is dividing the chord into two equal parts. Then you must be able to say, therefore, the angle between the two is 90 degrees. So the flip side of it, or the converse of the theorem, if the line from the center of a circle is making an angle of 90 degrees here, then it follows that the chord has been divided into two equal parts. So in an exam situation, if you are told that the chord is divided into two parts, then the angle is 90 degrees. If you are told that the angle is 90 degrees, it follows that the chord is divided into two equal parts. The condition is one. The line must come from the center of the circle. It can't come from anywhere else. It's not just a line, because I can have a circle and have a chord which is divided into two equal parts like this. But if this line is not coming from the center, then the theorem does not apply. The line is from the center to the midpoint of a chord. Where the line is coming from, it's necessary to please know. That is the first theorem that we teach the grade 11s. You need to know line from center drawn to midpoint of the chord is perpendicular to the chord. Now, how do we prove it? That is now important for us. How do we prove the theorem? So when you're proving a geometric question, you need to take notice of what information do you have and what do you want to show. What information do you have and what do you need to show? So let's say we are given, so our given information here, so let's take it that the 90-degree angle is not there, but what we are given is that line AM is equal to MB, which means the chord is divided into two parts, and we need to show that the angle at this point is equal to 90 degrees. So to start your calculation, you do some construction. You draw a line from point O to point A and from point O to point B. So we connect this point O to A and point O to B. Then at point M, it's necessary to label those two angles 1 and 2 just for convenience purposes. So that is the construction that we do. So the examiner will be kind enough to probably give you 1 mark for that construction. Your paper 2 is out of 150 in the final. So if you get 1 mark, you're left with 149 to get 150 out of 150. Now, after drawing this line, identify 2 triangles that are congruent to each other and prove that those 2 triangles are indeed congruent. So my triangles in this case are going to start from point O, OAM, and triangle OBM. I need to remember something about circles. The line from O to A and the line from O to B, those 2 are exactly the same. OB is the radius of the circle, so OA is the radius of the circle. That means OA and OB are exactly the same. Now, when I do when I notice that, I also notice that these angles are the same, but we don't need that information for now. Let's just stick to this. How do I prove congruency? You compare the sides of the triangles. The first letter to the next one, the first letter to the second one. Line O to A and line O to B. Are those 2 lines equal or not? In our case, they are equal because OA is the radius and OB is the radius. So our reason is radii. Then we compare the second one to the third one and the second one to the third one. That is line AM and MB. That is what we are given here. So therefore, our reason for that one is given. Then we compare the outside measurements from O to A to M and O to M. OM, we see that it is the same line, so we say it's common. We have 3 sides that are equal. If all 3 sides are equal, it follows that triangle OAM and triangle OBM are congruent to each other. And the case of congruence is side, side, side. Now, because these triangles are congruent to each other, if 2 triangles are congruent, it means they are identical. It follows that the angle you find at the first letter O and the angle at the first letter there, those 2 angles are exactly the same. The second letter and the second letter, they have the same angles. M, the third one, and the third one, they also have the same angles. Now we need to notice that